Hello everyone, today we're going to be doing Leetcode 424, longest repeating character replacement. The problem says you are given a string s and an integer k. You can choose any character of the string and change it to any other uppercase English character. You can perform this operation at most k times. Return the length of the longest substring containing the same letter you can get after performing the above operations. In example 1, we have AB, and k is 2. So you can change at most 2 times. So let's say we change B to A and the second B to A. It'll be A, and the length of this is 4. And same and vice versa, if you were to change this to all B's, the length would still be 4. So let's use example 2 as a test case on how we can solve this problem. B, A, B, B, A. So the approach I'm going to be going with is using a hash map. And the time complexity will be O of n, and the memory, the lookup will be, the space complexity will be O of 26, which is linear. So let's start off by drawing out the hash map. So we have key value pairs, and the key of the hash map will be the character that we're holding, the character that we come across, which is A, and the value is how many characters we have of that character, or how many numbers we have of that character. So 1, 2, 3, 4. So we have 4. And for B, we have 1, 2, 3. And the reason why we want to use a hash map is because there's a trick to solve it. We have this variable called k, and it shows how many times you can change. And basically, we're going to combine this hash map with the sliding window technique. And what we're going to do with that is we have a condition where if the window length minus the max of the hash map values, so the max of the hash map values is A in this instance, so 4. So minus 4, if that's greater than k, the integer k, we can update our hash map, so we can deduct this by 3. So deduct this by 3. And also shift the left pointer, so we can shift the window. And this is the most optimal approach I can find to solve this problem, and most intuitive. There's other solutions that are on Leetcode, but this is the most optimal solution that I can come up with. And basically, let's start off by running through this test case. So at first, we're going to have 2 pointers, left and right. They're both going to start at the beginning. So the window is going to look like right here. And left and right is right here. So that's initially. So is A currently in here? A is not currently in here, so we set it as a key, and then we have its value initially as 1. And currently B is not in here. And now, does this condition still hold? Does the window length, which is 1, so win length minus max frequency, if that's greater than k. So does this condition hold? So does 1 minus 1, is that greater than k? So let's say k is 2 in this instance. That's what the example has. K equals 1 actually. Is 0 greater than 1? No, it's not. So we don't enter this while loop. So we can just safely shift the right pointer, and the window will increase. The window now looks like this. Now we have, is A currently now we update A, which is 2. So this is the first iteration, this is the second iteration. So now, does this still hold? So does 2 minus 2, is that greater than 1? No, it is not. So we never enter this while loop. And the while loop, remember, this while loop, it updates, it deducts one from the max. Let me just write this out in text. It deducts 1 from max, and it shifts left pointer. So we're shifting the window over here. So that's if we enter this while loop. So now we can increase our window of our right pointer. So now the right pointer is right here, and the window is right here. So now we're into this iteration. So now we have the window length, which is 0, 1, 0, 1, 2. By the way, we're getting the window length by using the sliding window trick. This is right minus left plus 1. This is accounting for the 0 index. So right now it's 2, so it's going to be 2 minus 1, 2 minus 0 plus 1. So it counts for 3. So 3 minus the max frequency. In this case, we have to throw b in here. So b is 1. In this case, the max frequency is 2. So it's 3 minus 2. Is it greater than 1 yet? No, it's not greater than 1. So we can safely shift the right pointer, and it didn't enter the while loop. Sorry. Okay. So now we can safely shift the window. The right pointer is going to be right here. Let's use a different color, actually. Okay. So we have the left and the right pointer. The right pointer shifts. Now we're over here. Now we update our hash map. A is now 3. And now we check for this while loop again. The size we have of the window is 4. Is 4 minus 3 greater than 1? No, it is not. So we never enter this while loop. We just update our window. And we also move the right pointer. So we move the right pointer. The pointer goes right here. It's our right pointer. All right. So now we update our hash map. We come across a B. So B is now 2. This is the second B we came across of. So B is 2. So now it's going to be 5 minus 3. Is that greater than 1? Yes, it is. That equals 2. So 2 is greater than 1. So we deduct 1 from the max, and we also shift the left pointer. So we deduct 1 from the max, which is right here. So this becomes from a 3, it becomes a 2. And we shift the left pointer. So this is the left pointer. We shift it. Now we do the check again. In the 6th iteration, we're going to check is 4 minus 2. So the max of these, they're both 2, so we can just choose either one. Is it greater than 1? 2 is greater than 1. So we shift the window again. And by the way, we're going to be holding a result variable. And that variable is going to be holding the max of right minus left plus 1. So it's going to be holding the max of right minus left plus 1. So we were right here, sorry. Now we shift the window again. So left moves over, and we update our thing, our hash map, and it'll be 1 now. So now we check is 3 minus the max frequency, which is 2. So 3 minus 2. Is that greater than 1? No, it is not. So we can safely move our right pointer. And this is our window right here. We update our hash map. This is the 3rd B we came across of. So now we have a length of 4. So the window length is 4 minus the max frequency, which is 3. So is 4 minus 3 greater than 1? No, it is not. So we can safely move our right pointer. So the right pointer will be right here. This is the left pointer, right? So now we update our table. This is the second one we come across of. So this is now going to be 2. And now we check through this condition. Okay, now we check, is the window length, which is 1, 2, 3, 4, 5, is 5 minus the max frequency 3, is that greater than our window? And is that greater than k? And yes, it is, because that equals 2. So we shift our left window, or we shift our left pointer and update the table. So our left pointer goes right here. And this is the window right here. And we take off 1 from B, so that's 2. And now we check again. Is 4, so now is 1, 2, 3, 4. The window length is currently 4. So is 4 minus the max frequency, which is 2. We can pick any one. So is 4 minus 2 greater than 1? And yes, that is, because it equals 2. So we have to shift our window again. So the window now is right here. Now we update our table. This becomes a 1. Now we check. The window size is currently 3. 1, 2, 3. Is 3 minus the max frequency, which is 2, greater than 1? No, it is not. So now we can safely shift our right pointer. And our right pointer falls out. And we hit the end of the for loop. And we have a result variable to hold the maximum of the window that we could possibly have. So res will equal the max function of res and right minus left plus 1. So in this scenario, we're going to have a value of 4, because this was the value we had where it sustained all conditions, where it didn't enter the while loop. So for example, we had a window length of 4 right here. This was the scenario where it did not hit the while loop. And this was like this is the scenario where it did not hit the while loop. And it basically passed it did not hit the while loop, so it went into this res function. And it calculated it, and that's the max it kept holding. If you were to look right here, the while loop got hit, so this did not pass. The while loop got hit right here, so this did not pass. And over here was another scenario. So we have one scenario, 2 scenarios where it got calculated as 4 as the max. And over here it was 2, so this failed, and this passed. So if you were to do check marks, this was good, this was good, this was good, this was good, this was bad, this was bad, this was good, this was good, and this was bad, this was bad, and this was good. So this was when the scenario where our windows was updating in the result variable. So yeah, hopefully that makes sense. Now let's start coding it up. As I'm coding, I'll try to show you every line I'm doing. So right now we're going to initialize our hash map. So this is where we initialize our hash map right here. And now we want to run a for loop. Actually, we want to initialize our left pointer. So we want to initialize our left pointer because we want to do a sliding window, and our right pointer. And we want to have a result variable to return this value, this integer value. So initializing our right pointer, we will just do it in the for loop. So we're going to do for r in range of the length of s. We want the indice. And basically, now we want to do throw values into our hash map. So for count of s of r, so count of s of r is the key. So this is the key right here. And basically, we're trying to say for A, what do we want to do with the key A? So A is currently the key, B is currently the key. So whenever we come across a value that we've seen, we're going to add 1 plus count.get s of r 0. So count.get tries to get it gets the values of the key. And basically in this scenario, it will try to get, let's say we're in this scenario right here. It will go in the for loop of the hash map, and it will check that A already exists in the hash map with a current value of 1. So 1 is currently, if we're in this iteration, 1 is what currently the key holds. It's going to see that, and it's going to add 1 plus 1 to that. But let's say we hit this scenario where we see B. So to actually just restart it, it's kind of confusing to explain. So let's say we're in this scenario, right? We haven't encountered an A yet. So we're going to initialize an A, and count.get is going to return a default value of 0 because it's currently it currently has no values in the hash map yet. So we're going to throw A in there, and we're going to do 0 plus 1, which equals 1. So that's basically what the 0 does. It returns a default value of 0. And for the second iteration, count is going to run this. So count.get is going to do 1 plus count.get. So it's going to get the value that we know it was 1 earlier. And then it's going to do 1 plus 1, and it equals 2. So this becomes a 2. And now we're at this scenario. We're going to check, is B currently in the hash map? So count.get is checking, does B currently have a value in the hash map? It does not, so it's going to return a default value of 0. So we're going to do 0 plus 1. So when we do 0 plus 1, it's going to be B1. And that's basically how that works right there. And like I said, we're going to have this while statement. So we're going to have while the window length minus the max frequency is greater than k. So while the window length you can calculate it by doing right minus left plus 1. So while right minus left plus 1 is greater than plus the max of count.values. The reason why we're doing count.values is because we want this whole, let me control Z back to this. We want the values. So the max function is just getting the max of this. So in this scenario, the max will be 2. So it will be B right here. But the max function returns an integer, so it will just return the 2. So plus the max of values, if that's greater than k. So if that's greater than k, what do? We deduct 1 from the max. So we're going to do count of s of left minus equals 1. So the reason why we're doing count of s of left minus equal 1 is because let's say we're in this scenario. So left was right here. And then let's say so A, B, A. Let's say right was right here. We're going to do so let's say left and right was right here, right? We're going to want to deduct this A out and shift it. Let's say that this hit the while statement and shift it, and L will be right here. So we want to just get rid of this A right here, basically. That's why we want to remove 1 from the hash map. And we want to also shift the left pointer. Okay, so we shift the left pointer, and now it's time to calculate our result. So res equals max of right minus left plus 1, or res. And then all you have to do is just return res. And let's see if this code works. It does not work currently. Let's see why. So the output is 1 and the output is 0 in this scenario. So let's see if we did our code correctly. So we have for r in range the length of s, count of s of r equals 1 plus count.get s of r. That's correct. So while r minus left, this is why it's incorrect. So while r minus left plus 1 plus max of count.values is greater than k, we're actually supposed to subtract it. I made a mistake right here. So once you subtract it, it should be good. There you go. And the time complexity of this, let's submit first. It's a pretty efficient solution. There you go. The time complexity of this is O of n. And the space complexity is O of 26, which is linear, so it'll become O of 1. And yeah, hopefully you guys understood this this explanation. Thank you very much. Please subscribe for more videos like this. Have a great day.